Hi, to begin today, I'd like you to use a calculator and find the value of the square root of b squared minus 4ac in the following cases. 5 questions. Giving your answers to 3 significant figures when not exact. This is revising substitution and rounding, and there's a few little technicalities going on. So pause the video, try it out, and I'm going to go through them. So here are the answers. If you got them all correct, then I'm sure your substitution's in a really good place. I'm just going to show you where you might have gone wrong. So the first one it's going to be the square root of 7 squared. Notice I put the square root first and then I write it. If you've got a calculator like this, it really helps. 4 times, I actually don't need to times by 1 because it doesn't do anything, but I've just put it in anyway. And I get an answer of 3. Now, I wonder if for the second one you did this and got an error, because it's not actually this. You have to put a bracket around it. If you do minus 7 squared, you square the 7 and then you make it negative. But actually you want to do minus 7 all squared, so you need a bracket around it. So just be careful when you've got a negative for your b. And then we get the answer of 3 again. It's exactly the same. So having said that, you might be able to see, if you went wrong on any of the others. So this is going to be 3. I suppose if you're unsure, always put a bracket around it here, but you don't need it if it's positive. So it's going to be minus 3 squared and then 4, this time times 2, and then I'm timesing by minus 4. Note, by the way, this is going to make it, I'm going to be adding something because I'm minusing something that's times by negative. It will add together, and I get square root of 41, 6.40, round it there, and keep it at 0. Let's keep going, just modifying it. I can get rid of the bracket now. You can keep it there if you like, but I'm going to get rid of it. 8 squared times 4 times 2 times minus 7, which gives me 2 root 30 or root 120, same thing. 10.95. Just be careful here when you round it up, the 9 goes to a 0 and you make it 11.0. Even though we know that root 121 is 11, this is close enough to round to 3 significant figures to be 11.0. And the last one, root 5, 2.2. Oh, wait a minute, that should have been 2.24. You might have been questioning that one and you would have been right. There we go. Okay, brilliant. Now, how about solving x squared plus 3x plus 1 equals 0? We've been solving quadratics in recent lessons. Have a go at this. You might immediately think, no, I can't solve that, or you might try and find factors, but actually the only factors that could work are 1 and 1, and that would give me 2. So here, this doesn't work, and this is kind of where we're going with this lesson. We're going to be actually using this bit at the start, combining it with equations that we don't know how to solve. I just gave you a little sneak peek here, but we cannot factorize this. There's no factors of 1 that add to give 11. Sorry about the spelling. However, there is a method, a different method to factorizing that we can use for solving quadratic equations that are not factorizable. And that's what we're going to look at today. It's called the quadratic formula. And here is the quadratic formula. If you write an equation as ax squared plus bx plus c equals 0, where a is not equal to 0, then you can straight away write the solutions down as this: x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. In our case, back up here, we've got that a is 1, we've got b is 3, we've got c is equal to 1. Those are the numbers in front of the x squared, the x, and by itself. Notice if it's just x squared by itself, then yes, the number is 1. Like 1x is equal to x, 1x squared is equal to x squared. We call a, b, and c coefficients, the numbers in front of the things that are changing. Remember, x's can take different values, potentially anyway, especially if you've got y equals x squared plus 3x plus 1. So a is the coefficient of x squared, b is the coefficient of x, just x, and c is the coefficient by itself, technically the coefficient of x to the 0. Where did this come from? You might be thinking. That is actually not for today. I mean, formulae just don't come out of nowhere, but we need to do a bit of other maths first. But we're going to start off by learning how to use this formula, and then once you're familiar with it, we're going to do the maths that allows us to obtain the formula. It's really interesting, but it's I think it's best to look at the formula first. So hopefully that makes sense. We can, you've got to trust me, I suppose, that this does work, and also you need to learn this formula. Just to say, this might be the first time you've seen a plus and a minus. There are actually two solutions to quadratics normally, as you'll know. So one solution is when you take the plus, and the other solution is when you take the minus. And we need to find the square root of this thing here like we did at the start. So I want you to write this formula down 5 times. I mean, it's going to take more than 5 times to remember it forever, but it's a good start. I'm going to do it as well. So do it along with me. X equals minus b plus or minus b squared minus 4ac square root all over 2a. Okay, well done on that. So yeah, it's gone into my brain a little bit more. Hopefully, the more you use it, if you just maybe write down the whole formula every time you use it, it will slowly get there. That's the aim anyway, because you do have to learn it. So, just in case you're not sure what I mean by A, B, and C, we're going to practice a little bit. It's going to give you a little sneak peek again. Here are the numbers in front of x squared, x, and the number by itself. So, try this out. Even if you're just thinking it or writing it down, what are the values of A, B, and C in this situation? A equals 3, B equals 2, and C equals minus 5, not just 5, but minus 5. This one. A equals 4, B equals minus 3, and C equals 0. We should include that. We should say that there's no constant. Next one. This time A equals 9, B equals 0, and C is equal to minus 15. Here, A is equal to 0, B is equal to 7, and C is equal to minus 4. In fact, this one is not a quadratic. There's no x squared term, so you can't actually use the quadratic formula. As you saw here, A is not allowed to equal 0 to be able to use that formula. You can solve this by adding 4 and dividing by 7, of course. What about this one? Did I catch you out? A is actually equal to 3, and B is equal to minus 2, and C is equal to 5. It does. If you're not sure, then rewrite it. Always try and rewrite it in the the order that we've looked at. So your x squared term is first. So just be careful with those sorts of ones. Here, Well, here we will need to rearrange it, so I'm going to rearrange it. So it's x squared minus 3x minus 4 equals 0. So a is equal to 1, b is equal to minus 3, and c is equal to 4. And one more. Again, we'll need to sort this out. So I'm going to get 3x squared minus 5x equals 2. I'm going to minus a 2, and then it falls out. A equals 3, b equals minus 5, and c equals minus 2. I'm trying to take it slowly just so you're so confident, and now you can basically, once you've got that, all you need to do is substitute it into our starter and do a little bit more. Like you've got to do the minus b, the plus and the minus, and the divide by 2a. Let me show you. So let's do one example. Right, we're now going to actually solve that quadratic that we couldn't factorize. So first step, until you become really confident, let's write it down. X equals minus b plus or minus b squared minus 4ac all square rooted over 2a. I'm going to write down what a, b, and c are. So a is 1, b is 3, and c is 1. Now I'm ready to just, sometimes people say work all the terms out separately, but we've got a calculator that can deal with it. The main thing is don't start with the square root button, start with the fraction button, because we're already setting it up then. And then it's going to be minus 3. I'm going to do plus to start with. Remember, I've got two solutions. Square root 3 squared minus 4 times 1 times 1. Okay, I'll put them in. Actually, that's going to just be 4. Press down to get to the bottom, and then it's going to be 2 times 1. So I get minus 3 plus root 5 over 2. I'm just going to write that one down. Or, oh, I've forgotten. I need to do the minus. Sometimes there's another calculator that does this all for you. But actually, before I put that in, I should work out the decimal. Minus 0.3819. And I'm going to round this one to 3 significant figures. Minus 0.382. You might think I'm going to extremes here, but I'm just being really careful, which is definitely what you should do in an exam situation. Okay, write down your exact answer and then round it. So my second solution is when I put a minus in. And now I get minus 3 plus root 5 over 2. Actually, if I expanded this out, it would be minus 3 minus root 5 over 2. SD minus 2.618. Okay, I'm not going to write it out to loads. Then I'm going to round it, minus 2.62. And we are done. We've managed to solve a quadratic. Yes, it didn't factorize, but there are solutions. Just for info, it actually does, and this will be potentially useful, it does factorize. It's just, when you factorize a quadratic, and you factor, you get x minus 1, x plus 2 equals 0, and then you get the solutions x equals 1 or 2. You basically take the negatives. You can do exactly the same thing here to factorize it. You can write down that it's going to be x minus root 3 plus, minus 3 plus root 5 over 2. And you can multiply by x minus, so it's just going to be 3 plus root 5 over 2. That is actually the fact. It's not that we can't factorize it, we just can't factorize it with nice numbers. And you're not going to think up that to get it. But if you multiplied this out, it would actually get back to here. And you could be given the solutions and asked to work back to the quadratic. So this is not just a point of interest. This can potentially be useful. Okay, have a go at this second one yourselves. So I'm not going to go through the whole method here. That's what you should get. 7 plus root 17 over 2 and 7 minus root 17 over 2. Rounded answers as shown. 2 more to try. So A is 2, B is minus 1, and C is minus 9. This is what you should have got. Notice writing the answers exact, and then rounding straight away, you might put in this intermediate step, but like where you show how you've rounded them. If you did round incorrectly, then you'd lose some credit. It's always good to write it to a bit more accuracy and then round it, especially in an exam situation. And this final one, here's the answer. So actually, first of all, you need to rewrite this one into our form equal to 0. And this one does actually factorize. So, the point of this is that the method works whether you can factorize it or not. Here it would be 3x and x, and then you get minus 2 plus 1, from which the solution would follow. But you've hopefully done it using the quadratic formula. I'd like to try a few more questions. Using the quadratic formula, giving you answers to 3 significant figures where appropriate. And then we'll get on to some slightly different takes on this lesson. Pause the video, try these 8 out. Alright, I'm going to reveal the answers. So hopefully you're really careful with your rounding. Hopefully I was really careful with my rounding and that we're all in agreement. So these ones you're just putting in A, B, and C straight in. Here you have to rearrange to make C minus 2, only minus 2 from both sides. Here A is actually going to be minus 2. You could, in fact, add 2x squared to both sides, minus 3x and minus 10, and turn it into that sort of quadratic, so A is greater than 1. But it's okay to put it in as negative. Here, expand the bracket and rearrange. And finally, expand that bracket, rearrange it. I think you get 2x squared plus 2x minus 5 equals 0. I tried that one earlier myself, and this is what you get as the answer. How about this question, applying, well, not going to say any more, give it a go. So when you're doing questions, you don't know if it's going to turn into a quadratic that you can factorize or you can't. In this case, you need to set the area of the square equal to the area of the trapezium. They share a side, and that's how you're going to be able to solve for x. Remember, the area of the trapezium, I'll just write it down in case you've forgotten it. You need to learn this one as well, is a half a plus b times h, where your trapezium looks a bit like this. This is a, this is b. They're the parallel sides, and then the height is h. So that's all I've done in this case. I've rearranged it to make a quadratic, and now, if you were seeing this in I don't know, month's time, you might think to first of all factorize. It's going to be 10 and 3. That doesn't work. It could be 15 and 2, which doesn't work, or 13 and 1. And I think at that point we've exhausted all possibilities. It doesn't actually give you a hint. And I just realized I forgot to say, I don't know if I've said this, but whenever it says give your answers to 3 significant figures, that is basically code for it's not going to factorize. You know that you can be using the quadratic formula. If it doesn't say it, like in this question, then it's worth trying to factorize it, but then actually you can resort to the quadratic formula. You can actually, when you're solving an equation, you can always use the quadratic formula, but you should be able to factorize as well. So all those hours spent mastering factorizing was definitely not wasted. Here it won't, and when you substitute it in, you'll actually get 2 solutions. You reject the negative one, and 7.18 centimeters is the answer. A few more questions, different takes on it now. I'll show you all 3. try them out. So here I've given you sort of the quadratic formula and asked you to work back to A, B, and C. You get B really easily. It's going to be 6 just by looking up the formula, and A is going to be 2. And then substitute in, so it's going to be 6 squared minus 4 times 2, which is just 8C, and that's going to equal 12. And you can rearrange that and you get C equal to 3. Similar here, those are the answers. Finally, this is my challenge question really. What if I gave you the solutions to the quadratic and asked you to work back to the quadratic? There's a few ways of doing this, but I'm going to show you the best way. Now the best way is to jump all the way back to the start of the lesson, and if you remember how to, when you solve quadratics from factorizing, whatever's in the brackets, if you've got x minus a, x minus b equals 0, then you get x equals a or b. And so we can go, instead of going from down, we can go up. We can basically say that this thing here is going to be a, and this thing here is going to be b. So for my quadratic, it's going to be x minus 1 minus root 3. I know I've got a lot of brackets going on here. We'll get rid of them in a minute. And then x minus 1 plus root 3. And I've constructed a quadratic. But it doesn't want me to leave it like that. It wants me to simplify it. So first things first, I'm going to, you know what, it's whether you expand the bracket here or not. And arguably, it might be easier to not do it actually. So I'm going to leave the bracket in. So when I expand this, I'm going to just do I'm going to still treat this as a and this is b. So I'm going to get x squared minus 1 plus root 3 x minus 1 minus root 3 x plus, and then it's a double negative, so I'm actually going to get 1 minus root 3 times 1 plus root 3. Still doesn't look particularly nice, but let's just keep going. In theory, it could be a third answer, but we're actually going to get integers here. So I'm going to get x squared minus x minus root 3x when I expand this bracket, because I've got a minus here. So I've done 1 times x and root 3 times x, and I've included the negative. And then I'm going to get minus x. But here I've got minus times minus, so I'm going to get plus root 3x. And that is great news because these just cancel out, and suddenly it's looking a lot easier. Then I'm going to expand this out. I'm going to get 1. I'm going to get a plus root 3. I'm going to get a minus root 3. And I'm going to get a minus 3. These again cancel. So suddenly it just becomes x squared minus 2x minus 2. And that is our answer. That is the quickest way of doing this question. I don't think I'm going to talk about other ways. You could, actually I'll quickly talk about one other way. Because I once did this, it's not a good way. You could write it as x squared plus bx plus c equals 0, and substitute your solutions in. You'll create simultaneous equations for b and c, which you'll then have to solve. You know what? Don't do that. But it's just like, it's good to talk about other ways you could do it. This is the best way, as long as you've got this understanding that goes on here. Okay, brilliant. Well done with using the quadratic formula. We are going to see where it comes from. Honest, we'll get there. It's just not today wasn't the day. Today was about using it and becoming somewhat familiar with it. Just to finish, what I challenge you to do is, without looking at it, can you try and write it down? Write down the quadratic formula from memory. I'm going to give it a go. Very easy to get these terms mixed up. The more you practice it, the more you write it down, the more you'll remember it. Brilliant.